All right, guys, this video is going to cover notes 8.3. This will be day one of special right triangles. So to start off the notes, we want to go ahead and just look at the warm-up. It says, using Pythagorean theorem, find the length of the hypotenuse of both triangles. Leave your answer as a simplified radical. So they want you to find the length of the hypotenuse. Remember that the hypotenuse is the side across the 90-degree angles. So this is our hypotenuse, the number one that we're looking for, which we'll call x. Now, when we're doing Pythagorean theorem, we said that c represents your hypotenuse. So I'm going to label that as c. This will be a. This is b. Recall that Pythagorean theorem is a squared plus b squared is equal to c squared. And if we start to plug our values in, we're looking at a and b are both 3. So we're looking at 3 squared plus 3 squared is equal to c squared, which is x squared. And if we start to work this out, 3 squared is 9, plus another 3 squared, another 9, is equal to x squared. Adding those values together, we get 9 plus 9 to get 18. So 18 is equal to x squared. Now, if we're to solve for x, we would need to square root both sides. And as we look at this, the word of 18, we're going to notice that that's not a perfect square. So what we're going to have to do is look at simplifying that radical. 18 can be broken down into 2 times 9, 2 is prime. This can be broken down into 3 times 3. So what we're going to do is we're going to replace that 18 with 2 times 3 times 3. So that would be equal to, and then remember that that square root cancels out with the squared, so we're left with just x now. And the way that this works is we're looking for a pair of the same numbers. We see that we got a pair of 3's here. That means that 1 3 comes out, and we're left with just a square root of 2 underneath the radical. So our value for x here is equal to 3 square root of 2. So I'm just going to write that here so that we have this for reference later. This side is 3 square root of 2. Now let's look at example number 2 for our warm-up. Okay, again, they're asking for the same thing to find the length of the hypotenuse. The hypotenuse is the side across the 90, so we're going to call that x. And when we're doing Pythagorean theorem, we're looking at a squared plus b squared is equal to c squared, where c is your hypotenuse. So there's c, we'll call this a, we'll call this b. Plugging our numbers in, we're looking at 4 squared plus 4 squared is equal to x squared. If we square the 4, we're looking at 16 plus 16 is equal to x squared. Adding those numbers together, we get 32 is equal to x squared. If we're going to solve here, we need to square root both sides. Doing so, we're left with the square root of 32, which is not a perfect square. So again, we're looking at breaking this down to simplify it. We can break this down into 2 times 16, 2 is prime. This can be broken down into 4 times 4. 4 can be broken down into 2 times 2. And what we notice here is the square root of 32 can be replaced by a total of 1, 2, 3, 4, 5 twos. So we're looking at 1, 2, 3, 4, 5 twos. And that's equal to the square root canceled out with the squared, leaving you with just x. What we're looking for now is a pair of the same numbers. We see that we have a pair of 2's. So that means 1, 2 comes out. We have another pair of 2's. So that means another 2 comes out. We're going to multiply those. And all we have left underneath the square root is just one singular 2. So this ends up becoming 2 times 2, which is 4. So we have 4 square root of 2 is equal to x. And so kind of like we did in the last one, we're just going to write out what we have here. We have 4 square root of 2. Okay. And so the next part of the warm-up is asking, what pattern do you notice? Okay. Specifically, we want to be focusing our attention on the side lengths for our right triangle. We have 3, 3, 3 square root of 2. In the second triangle, we have 4, 4, 4 square root of 2. Okay. The pattern that you guys are hopefully realizing here is when the legs are congruent. So remember, our legs are A and B in this case. When the legs are congruent, then what we're noticing here is that the hypotenuse is going to be the leg length, which in this case is 3, multiplied by the square root of 2. Same idea over here. My hypotenuse is the leg length of 4 multiplied by the square root of 2. So when the legs are congruent, then the hypotenuse equals the leg times the square root of 2. And so that's the pattern that we're trying to get you guys to realize here. And you'll notice that this happens whenever the legs are congruent. And the only instances where the legs are going to be congruent in a right triangle is whenever we have the angle measures of 45 degrees on both of these angles. Same thing is happening over here. So 45 degrees and 45 degrees. When you have a right triangle that has a 45, 45, 90, what you'll start to realize is the hypotenuse is going to be the like length multiplied by the square root of 2. And so this is kind of the whole basis behind our notes for today. What we're looking at today is special types of right triangles, and this happens to be the first one that we're going to look at. This is known as the 45, 45, 90 special right triangle. And so the way that this works is in a 45, 45, 90 special right triangle, the legs are going to be congruent. And I like to label my legs as A. Okay, so my legs are A. If my leg is A, based off of the conclusion we arrived at from the warm-up, the pattern that we saw was that the length of the hypotenuse is going to be A multiplied by the square root of 2. So your hypotenuse here will be A times the square root of 2. Okay, and you'll notice that in a 45, 45, 90, the legs are always going to be congruent. The legs will always be A and A. Right. So what we're going to do is we're going to use this pattern that we have going on whenever we have a 45, 45, 90 special right triangle with the a squared to 2 to solve for some examples down below. Okay. So in the first example, and for any example really, what we're going to focus our attention on is what are the angle measures inside of our right triangle? Well, if I see here that I have a 90 and I have a 45, I'm only going to do this one time, but if we wanted to find that third angle, we would do 180 minus 90, which is 90, and then minus the second angle of 45. This would tell us that that third missing angle right there would be 45 degrees. Okay. And so that would be the first thing you want to start with in every special right triangle problem is fill in all of the missing angle measures. So we see that that's 45 degrees. So what you would do next here in this case is we would label the right triangle according to the pattern that we have here. Okay. Our legs, which are congruent, we like to label those as A and A. Our hypotenuse is going to be labeled as A square root of 2. Now, in every single one of these problems, they're going to give you one of those side lengths, right? And so this is what we're going to focus our attention on. The side length that they gave us was 10. So what we're going to do is we're going to write an equation with the given side length. So we can say here that A is equal to 10 based off of the provided side length. And so if A is equal to 10, the question here is asking you to find the values of X and Y. Well, X is labeled as A. So if we see here that X is equal to A, well, we just found out that A is 10. So that would mean that X is equal to 10. So we can say X is equal to 10. Similarly over here, we see here that Y is our A square root of 2 side. So if Y is equal to A times the square root of 2, then what we can basically do here is we know our A value is 10. Take that A value of 10 and plug it in here. So Y would be equal to 10 times the square root of 2. And that would be the values for X and Y for this first example. And that should match up here with kind of what we had listed up above in our pattern. What we're saying here is that, well, this side is already labeled as 10, but that would mean that this side is 10, and our hypotenuse is 10 times the square root of 2. And so that's the generic pattern you're going to see happen in every 45, 45, 90 right triangle. Let's do a couple more examples because you are going to run into different scenarios here. So let's look at number 2. Number 2, okay, again, we're going to start off by labeling our angles, right? If this is a 90, if this is a 45, then this third angle must be 45 degrees. From here, what we're going to want to do is we're going to want to label our sides according to our pattern, right? The legs are going to be labeled as A and A. So here are my legs that are congruent. This will be A, this will be A, and our hypotenuse, which in this case is given to us, we're going to label it as A squared root of 2. So after you've labeled your 45, 45, 90 special right triangle, we're focusing our attention here on the side length that was provided. They gave us the 8 square root of 2 side, which represents the A root 2 side. So we're going to build our equation based off of the given side length. So what we can say here is that my A square root of 2 side is going to equal to 8 square root of 2. Now, the objective here is we want to find the value of U and V. The only way I can find the value of U and V is if I find the value of A. So really the objective here is we want to take the equation that we just wrote down and solve for A. So this right now reads A multiplied by the square root of 2. How would I solve for A? How do I cancel the multiplication of square root of 2? By doing the opposite. Opposite of multiplying by square root of 2 would be to divide by square root of 2. So we're going to do that on both sides. What ends up happening here is that the square root of 2's cancel, leaving you with just A is equal to, well, over here we have 8 square root of 2 over square root of 2. The square root of 2's here also cancel, leaving you with just 8. So this is extremely important. Pretty much in every problem, you're going to want to find the value of A. We have found the value of A here. We found out that it's 8. So we can build our other equations. Here we see that U is equal to A. So if u is equal to a, we just found out that a is 8. So we can say u is equal to 8. So u is equal to 8. Similarly over here, v is also equal to a. So v is equal to 8 because we found a earlier to be 8. And this should make sense because in our 45, 45, 90 special right triangle, you're going to end up realizing that the legs are congruent. So I have 8, 8, and 8 times the square root of 2. Again, still following the pattern that we saw in the last example and in the warm-up. Let's look at number 3 now. Okay, number 3 now, something a little bit different happens. And let's just go through the steps here a little bit faster now, just at least the labeling part. So if this is a 90, this is a 45, then this is a 45 degrees. And if we label our sides here, our congruent legs are labeled as A, the hypotenuse is A squared root of 2. And in this case, the given side length that they gave us was this one. Our 3 square root of 2 here represents A. So I'm going to write my equation that says that. The given side length we have here is our A. So A is equal to 3 root 2. Well, if A is equal to 3 root 2, well, we can already find Y. Y was represented as, well, Y is my side length of A. So if Y is my A, we just already know that A is 3 root 2. So we can take this guy and just plug it in right there. So that means Y would also be 3 square root of 2. So Y is 3 square root of 2. But now as we look at X, take a look at what happens with X. X is my A square root of 2 side. So I'm going to write that X is equal to A square root of 2. And we know that A is 3 root 2. So we're going to take that and plug it in right here. Doing so, what that gives us is X is equal to A, which is 3 square root of 2. And then we have to multiply that by root 2. So we're going to multiply. Actually, let me color code this to where it hopefully makes sense. So again, what we're saying here is our value of A is 3 square root of 2. So we're plugging that in for A. So this is 3 square root of 2. And then we still have to multiply that by root 2. And so remember that when we're multiplying square roots together, you just multiply the numbers underneath the radical. So we're left with 3 times the square root of 2 times 2 is 4. So we have 3 times the square root of 4, which is, square root of 4 is 2. So we're left with 3 times 2. And if we multiply that out, then we get x is equal to 6. So here x is equal to 6. And we're pretty much going to follow the same steps for every single special right triangle problem that we see. To summarize, we label our missing angle if we have one, and then label your sides as A square root of 2. Create an equation with the given side length, and then with that, you can find your missing information. Okay, so let's look at our next 2 examples. These next 2 are a little bit harder. And as kind of a reminder here at the top, we're just going to label our 45, 45, 90, right? Remember that these are our congruent legs. We call these A and A. The hypotenuse is our A square root of 2 side. And so as we look at this, if I look at number 4, it says find the values of X and Y. Well, X and Y, before we start, we're looking at our angles. This is a 45, 45, 90. And these represent our congruent legs, our A and A. That means that this side is our A square root of 2 side. And so as we focus our attention here, the side length they gave us was 19, which represents our A root 2 side. So the equation that we're going to write is going to say that A square root of 2 here is equal to 19 based off of the given side length, right? And so if I want to solve for X, I need to find out what A is. So this equation that says A times the square root of 2 is equal to 19, we're going to solve this for A. So to do so, to cancel out the times square root of 2, we're going to do the opposite, which is to divide square root of 2 on both sides. That cancels, leaving us with A is equal to 19 over the square root of 2. Now, the only problem with this is we cannot have a square root in the denominator. So what we have to do is we have to rationalize this. The way that we rationalize the square root in the denominator is by multiplying the top and bottom by that same square root. So we're going to take this and we're going to multiply this by square root of 2 over square root of 2. What this does is we multiply straight across the top. This gives us 19 times square root of 2. And on the bottom, the square root of 2 times the square root of 2 would give us the square root of 4. And we would keep simplifying here. On the top, we still have 19 square root of 2, but on the bottom, the square root of 4 actually becomes 2. And so now we can kind of break this down to where we realize that A is equal to 19 square root of 2 over 2. Normally we would check to see if we can keep simplifying this, like if I could divide these two numbers and it gave me a whole number, the 19 over 2, but it doesn't. So in this case, we're just going to leave our a value as is, that a is equal to 19 root 2 over 2. Now the question was asking you to find the value of x and y. Well, remember that x is equal to a. Well, we just found a. So that means that x is equal to this amount, 19 square root of 2 over 2. So there's our answer for x. And then the same thing could be said for y because these legs are congruent, right? So because y is also equal to a, then we could also say that y is equal to 19 square root of 2 over 2. Right? And so these are the problems that typically require more work when you have a square root in the denominator and you have to rationalize by doing this process here in blue. Okay? So let's look at another one. Let's look at number 5. If we look at number 5, okay, we're going to start by labeling our missing angle. This is a 45. That means that this is a 45. And what we're going to look at now is labeling our sides. This is A, and this is A squared root of 2. Again, they gave us the A squared root of 2 side. So what we're working with is this 2 root 6. That represents our A squared root of 2 side. So the equation that we're going to write is going to say my A squared root of 2 side has to equal 2 square root of 6. And so same idea here. The objective, I mean, basically for any problem is, again, you just want to solve for A. Once you know the value of A, it kind of comes together a little bit easier. So if I want to take this equation and solve for A, we're going to divide both sides by the square root of 2. This cancels, leaving us with A is equal to 2 square root of 6 over the square root of 2. Now, you can go through the process of rationalizing the denominator. So if you wanted to do basically what we did earlier, you can. But if we can multiply square roots together, it's implied that we can also divide square roots together, right? So if we take a look at the square roots that we have in this fraction, the square root of 6 over the square root of 2, you can actually divide that. So as long as they're both under square roots, you can divide it. So what this is going to end up becoming is we have 2, and then let's divide the square roots. The square root of 6 divided by the square root of 2, you just divide the numbers underneath. 6 divided by 2 gives me 3. So this part in green becomes square root of 3. So our a value is 2 times the square root of 3. And if I want to find x and y, well, x and y are both equal to a. So x is equal to a, which we found out to be 2 times the square root of 3. Next, we're looking at y. Y is also equal to a. So y is also equal to 2 times the square root of 3. Okay. And so we're going to go ahead and finish up with the last example down here on the next section. And before we kind of finish up here with the last example, one thing that I do want to kind of explain here throughout the notes is what is the whole purpose of this 45, 45, 90 special right triangle? What this basically does is it gives us another way to solve for the missing side lengths of a right triangle. Pythagorean theorem that a squared plus b squared is equal to c squared, we can do that when we know 2 of the side lengths, but that's not always going to be the case. So for the problems that we're looking at, we only know 1 of the side lengths. So let's finish up with the last problem here and see kind of how this works out. So it says that a square has a diagonal that is 15 centimeters. Find the length of each side. So let's go ahead and draw this. A square, we're going to draw a square, has a diagonal that is 15 centimeters. Well, first, let's kind of talk about what a square is. Remember, a square is a quadrilateral with 4 right angles. And we also know that all sides are congruent. And so what we're going to do now is we're going to draw in our diagonal that is 15 centimeters. Here's our diagonal. It's 15. And they want you to find the length of each side. Well, one of the properties of a square that we learned about earlier this school year was that inside of a square, what the diagonal does is it bisects the opposite angles. So if I were to bisect this 90 degrees, and if I were to cut it in half, what that would create is 45 degrees. That would happen here at this right angle, and it would also happen here at this right angle. So what we're basically working with is another 45, 45, 90 special right triangle. What the question is asking you for is find the length of each side. Well, the length of each side, I'm going to call this side x. And because this is a square, we know all sides are congruent. So I can call this x, and this is x. What we can focus our attention on now is just this right triangle that I have outlined in yellow. So what I'm going to do to make that a little easier to look at is I'm going to separate that out off to the side. Here is our 45, 45, 90 special right triangle, where we see here that we have a diagonal of 15, and we have these side lengths of x. Okay, so if we're going to go ahead and work this out, then we can look at our pattern. Remember that when we label this, we label the congruent legs A and A, across the 90, our hypotenuse is a square root of 2. So what we're working with here is, well, they gave me the 15, so I'm working with my a square root of 2. So let's build an equation that says that. We're working with a square root of 2 is equal to 15. So if I want to solve for a to find x, then what we need to do is cancel this out. We cancel times square root of 2 by doing the opposite, so divide by square root of 2 on both sides. Doing so gives us a is equal to 15 over the square root of 2. But remember, we cannot have a square root in the denominator. So to rationalize this, we need to multiply the top and bottom by that same square root. So we're going to multiply top and bottom by square root of 2 over square root of 2. So if we do this, we multiply straight across the top. We get 15 square root of 2 on the top. And on the bottom, square root of 2 times the square root of 2 is the square root of 4. Continuing with this, 15 root 2 on the top stays the same, but on the bottom, the square root of 4 is 2. So what we see here is that a is equal to 15 square root of 2 over 2. And normally, again, we would try to divide this. But we see that 15 divided by 2 does not give me an even number. So we're just going to leave it as 15 square root of 2 over 2. And so we can finally answer the question now. The question asks you to find x. Well, x is equal to a based off of how we labeled this. And we already found a to be 15 root 2 over 2. So there's our answer. The length of each side is 15 root 2 over 2. Okay. The only thing we want to make sure that we're including here is, well, what units are we looking at? Are we looking at feet, inches? We're looking at centimeters here. So our answer is 15 square root of 2 over 2 centimeters is the length of each side of this square. All right. And so to kind of summarize here so that you know how to do these problems, the steps that we go through is label your 45, label your angles. After you label your angles, label your side lengths as a square root of 2, and then create an equation like we have here in green based off of the side that was provided and solve for a. All right, but that's going to be it for the video of special right triangles day 1. If you have any questions or found anything confusing about the video, please make sure you reach out to your teacher to schedule a time for tutorials.